control.
Okay guys, so our next lesson for today is all about the stability and determinacy of engineering structures. So first, let's define what are engineering structures. So let's proceed with the next slide. For that, ang ko lang yung marker, your pointer I mean. Okay, so engineering structure. The word structure has various meanings. So by an engineering structure, we mean roughly something constructed or built. So the principal structures of concern to civil engineers are the following. So we have bridges, buildings, walls, dams, towers, shelf, and cable structures. So these structures are composed of one or more solid elements so arranged that the whole structure as well as their components are capable of holding themselves without appreciable geometric change during loading and unloading. Okay guys, so these principal structures are mainly consist of the solid elements. So on the next slide, malalaman nyo kung ano ba yung mga elements. So the structural theory are ang ating i-discuss dito sa subject na to or this course subject ay iikot lang sa tatlong ito. So una, we have beam, truss, and rigid frame. Sa combination ng tatlong basic structure elements na to, dito nabuo yung mga structures, ating mga main structure or principal structure dito sa previous slide, yung mga bridges, buildings, walls, and etc. Okay, so i-define natin yung bawat isang structural element kung ano ba ang definition nito. Okay, so a beam. So let's define beam. So in its narrow sense, it is a straight member subjected only to transverse loads. A beam is completely analyzed when the values of bending moment and shear are determined. So ito yung main concern natin in analyzing a beam to get the bending moment and the shear. So itong mga to is kakailanganin natin sa pag-compute ng flexural stress, the horizontal shearing stress, the one we discussed in the mechanics of deformable bodies, and at the same time, yung kanyang mga deflection. Okay? So let's proceed with the next structural element, which is known as a truss. So what is a truss? Truss issues. Okay, kidding aside, so a truss is composed of members connected by frictionless hinges or pins. The loads on a truss are assumed to be concentrated at the joints. So again, yung mga members or structural members for the truss is connected by a frictionless hinge or pins. And sa mga connection na to, ina-assume natin that doon sa mga connection na yun nakalagay yung mga concentrated loads gagamitin natin sa pag-analyze ng isang truss problem. So each member of a truss is considered as a two-force member subjected to axial forces. And take note that a truss is normally assemble normally on a shape of a triangular shape. Next, what is a rigid frame? It is built of members connected by rigid joints capable of resisting moments. Members of a rigid frame in general are subjected to bending moment, shear, and axial forces. Sa frames, guys, ang kinocompute natin dito are bending moment, shear, and axial forces. So later on, as we progress in course subject, there are several ways in order for you to solve for the moment, shear, and the axial forces. Madali lang naman to, medyo mahaba lang yung solution, but there are three methods. Okay, so on the next slide, let's define what are the different type of support reactions. Kasi kakailanganin natin yan kapag nag-solve tayo ng determinacy of a structure. So ito is a parang review lang coming from your static of rigid bodies. The first one, we have here a roller support. So this is a one unknown element. So again, kapag roller ka, this is usually designated by a symbol na ganito, triangle with the two wheels sa baba, and the reaction is always perpendicular to the surface. Sometimes it is also denoted by a symbol na ganitong shape, bilog lang. And sometimes, yung iyong roller can act on inclined surface. So again, by the definition itself, it is always perpendicular surface. So we have 2 degrees of freedom. So ano bang ibig sabihin dito na? So diba dun sa ating equilibrium equation, meron tayong tatlong equation of equilibrium. So we have summation of forces x natin. So again, we have summation of forces x. We have also summation of forces y. And we have summation of. So since ang iyong unknown dito is one unknown element, sabihin, meron ka pang dalawang equation na pwedeng gamitin in order to solve for the. Kaya, nangyari, 2 degrees of freedom. Okay, so ang nangyari lang, so 3 minus 1, so dun mo malalaman yung degree. Okay, kaya naging 2. So next, we have the link or strat of a one unknown element. So this is usually symbolized by this symbol. So parang ano lang siya, popsicle stick na connected by a pin sa dulo. Ano? So ang reaction niya is the same lang ng parang kay roller. So again, it is always perpendicular to the surface. Makikita mo yung free body diagram dito ng link connection dito sa system na to. So you have link 1 and link 2. Okay? So yung force mo dito is always perpendicular lang sa. Kung nag-drawing ka ng free body diagram, ganito yung magiging pataas. So ganito lang yung kakalabasan. Ganun. So again, gaya nung kanina, so that is 2 degrees. So since 1 lang yung reaction niya and the available equation, tatlo, 3 minus 1, 2. Okay, so this time we will have hinge support. So this is 2 unknown elements. So kapag hinge, di ba may horizontal and vertical reaction ka. So a hinge is usually symbolizes by a triangular shape. Then sa bottom niya yung kanyang patong yung iyong beam. And then, so nandiyan yung reaction. And sometimes this reaction is symbolizes by this symbol. So parang kinuha niya lang yung resultant ng Rx. So yung horizontal reaction and Y reaction. So by Pythagorean theorem, mahahanap mo yung total resultant. Ano? So the degree of freedom of that is 1. So dalawa yung unknown mo. So mangyayari, 3 equation of equilibrium is 2 for the number. So, ibig sabihin lang yan, meron ka pang isang extra equation. Maalin dito sa tatlong pwede mo pang gamitin. Ano? And last will be the fixed support. So this is the unknown. So fixed support it symbolizes symbol. So anong nangyari lang dyan, naka-connect siya mismo. Ano? And that, we have 3. So you have a moment. Aside from that, you have horizontal, an x. You have also ry. So the degree of freedom of that is rho. Since the available equation of equilibrium is tatlo, mangyayari 3 minus the 3, the 3 own action, that will be 0. So, ibig sabihin niya lang, sapat yung tatlong equation of equilibrium para mahanap yung known. Okay, so on our next slide, we will now discuss how to know the determinacy of a beam. Okay, so a criterion may be established for the stability and determinacy of beam, where we let that R is the number of reactions. C is the total number of equation of conditions. So where C is equals to 1 if the beam has a connection of an internal hinge. So ano ba yung itsura ng ating internal hinge? So later on, sa next slide, magbibigay siya ng example ng internal hinge, pero para makita nyo na rin agad, ganito yung itsura niya. For example, you have here simply supported beam. Meron kang hinge and roller. And then doon sa gitna, meron kang makikitang itim na nasa pagitan ng dalawang beam. So ganyan po ang itsura ng internal hinge. Okay, so C is equals to 2 for an internal roller. So ano naman yung magiging itsura ng internal roller? So ganito yung itsura ng internal roller ha. So halimbawa, meron kang ayan, simply supported, and then meron ka ditong portion na overhang, and then sa ibabaw niya, meron pang isang beam. Sample. Okay, so pag ganito yung figure mo, ayan. So meron kang bilog sa pagitan ng dalawang beam, so that is considered as your internal roller. So saan yung value ng kanyang C is equals to 2. Okay? And the total number of equilibrium equation is determined using C plus 3. So saan nanggaling yung plus 3? Guys, again, for this type of problem, you need to solve for the unknowns. So, di ba meron ka summation ng forces x, forces y, and summation ng moment. So, yan yung tatlong available equation. Yung C mo is the additional equation na mapagkukuhanan mo. Kasi yung internal hinge, di ba ang pwede mong gawin dito, i-section mo siya, and then either i-consider mo yung magkabilang part. Same as for the roller. Ang nangyari lang sa roller, so meron ka magkabilang na reaction. Okay? So, let's solve some example and to know the category of the static stability and determinacy of beam. So for this, meron tayong tatlong category. So the first one, you have the unstable, kung saan the equation will be R is less than C plus 3. We have also the determinate if stable, if R is equals to C plus 3, and indeterminate if stable or R is greater than C plus 3. Okay, so paano ba ginagawa ito? So kung maaalala dati, di ba ito yung sinasabi ko sa inyong topic na kahit bata kayang isolve. So as long as alam mo yung equation, so again, for beams, pakitandaan na lang that R greater than, equal, or less than C plus 3. And then, ito yung mga different categories. So ang kwento pala niyan guys, before pala dapat kayo mag-solve ng problem, dapat inaalam mo kung anong category kasi ng beam na. Kasi, if indeterminate yan, so there's an additional equation na kailangan gawin para ma-solve yung mga unknowns. So determinate and stable, so ito yung normally na sinosolve natin na nakukuha lang ng summation forces x, y, and moment. And unstable, so if unstable ka naman, so therefore your structure will, or the beam system will be, or will undergo failure kasi nga unstable siya. Okay, so try natin yung example. So for this, palitan ko lang yung kulay ng ink. So ano nga ang kailangan natin? R. R is the number of resultant. C is the, balikan natin yung kanina. So C is the total number of equation condition. Okay, so for the first example, you have here a hinge supported beam. So ang support niya lang is nando sa left portion. So ito lang siya. Kung saan yung iyong hinge ay meron dalawang support. So again, meron kang dalawa. Okay? So, ito yung R. So, pangalan natin R. And, dito sa, sa C, or dun sa iyong equation of condition, so C is equals to 0, since wala naman na binigay na internal hinge or roller. Okay, so by applying the equation R is greater than or equals or less than C plus 3, therefore, our equation would be, again, ilan nga yung ating R? So, 1, 2. 2 is greater than or equal or less than C, so 0, plus 3. Therefore, 2 is less than 3. Therefore, this beam is papatak sa condition na unstable. Unstable. Okay, so kung mapapansin nyo rin guys, meron ka dito nga dashed line. And this dashed line means na bababa yung iyong beam kasi nga wala kang support dito sa kabila eh. Wala ang roller man lang. So ito, upon the application of load, bababa. That's why it is considered unstable. So normally naman, may bibigay naman sa inyong clue kung saan siyang category. Papatak. So kagaya nito, meron siyang dash line. So, ibig sabihin, bumaba siya. Okay, so the second problem. So try natin dito. So anuhin ko lang pawiin ko lang yung sinulat natin kanina. Okay guys, kayo naman. So for this beam, ano yung ating mga reaction? So tingnan ng reaction. So ano yung support na given dito sa problem na to? Tama! So meron kang dalawang roller. So base sa inyong napag-aralan sa SRB, ilan nga ang reaction sa roller? Correct! 1. So knowing that, you have here a perpendicular reaction acting upward. So this is R, and sa other end, that is also R. Okay, so meron ka bang nakitang internal hinge o internal roller sa ating figure? Tama. Yeah. Therefore, C is equals to 0. So when we apply the equation R is greater than or equals or less than C plus 3, our equation will be R. So ilan ang R sa ating problem? So sabay-sabay nating bilangin guys. So 1, 2. So R is equals to 2. Greater than or equals or less than C, which is 0, plus 3. So ano mangyayari sa equation? So 2 less than 0 3. Okay. So, less than. Ibig sabihin, unstable. So, if you're going to analyze the problem, kung makikita nyo dito, wala kasing horizontal support. So, ibig sabihin, kung magkakaroon lang yan ng kaunting horizontal external load applied, ibig sabihin, mag-i-slide yung iyong beam kung gagalaw siya papunta dito or papunta sa kabila. Depende sa applied external load. That's why it is considered unstable. Okay, so dumako naman tayo sa letter B condition or terminate and if stable if R is equals to C plus 3. Okay, so unahin natin yung unang example. So you have here a simply supported beam kung saan this point meron kang hinge and roller. So again, for hinge, ilan yung ating reaction? Tama. Isang horizontal and isang vertical. So ang R mo dito equals to. How about do sa kabilang support? Meron ka daw roller. So again, kapag roller, you have a perpendicular action that R equals to 1. So again, by applying the equation R is greater than or equals or less than C plus 3. So ang C natin, as you can see, wala ka naman condition na binigay na meron siyang internal roller or internal. So apply na natin yung equation. So for R, bilangin natin. So isa, dalawa, tatlo.
Ang galing mo pala dyan ah.
Tatlo.
Hindi ko alam ah.
So ito ay 3. So that is greater than, equals, or less than. So ang condition mo sa 0. Therefore, this is 3 is equals to 3. So that is considered statically determinate. Okay. Next example. So ito, parang kapareho siya dun sa kaninang unstable. Ang nangyari lang dito, meron kang tatlong support. So ang bawat support niya, so meron kang beam. So sa left end mo, meron ka dito na, pawiin lang natin yung kanina. So ano yan na lang ha, palagay na lang sa notes. Sagot. So dito meron kang, again, ang reaction. So again, ito ay roller, tatlong roller. So ibig sabihin lahat sila perpendicular distance, perpendicular based do sa support. So ito ay lahat ay pataas. So that is R. Okay. So meron siyang tigigisa. If you again apply the equation R is greater than or equals less than C plus 3. Again, wala ka namang internal hinge or internal roller ng bigay. That is 1, 2, 3. So 3 greater than or equals or less than C, which is 0, plus. So 3 is equals to 3. So this problem is papatak dun sa category na statically determinate. But as you can see, again, wala siyang horizontal reaction. So ito is magkakaroon ng additional condition but unstable based do sa support na condition binigay. Kasi wala ang horizontal support eh. So kapag nagkaroon siya ng external load na horizontal, so gagalaw siya, mag-slide as you can see here in the dash line. So pinakita niyang gagalaw yung iyong. Okay? And the last will be for the indeterminate if stable. So this is statically indeterminate. So in degree ng indeterminacy or yung additional equations na kailangan mo makuha ay mahanap mo if you find the difference between R and T plus 3. Para mas maunawaan, ipapakita na. Ano? Okay guys, so pawiin lang ulit agad natin ito. Okay, so ayan. So ano yun natin? Bilangin ulit natin yung reaction. Again, ang yung equation is R is equals to greater than, less than, or equals to C plus 3. So dito meron kang fixed support. Again, kapag fixed, meron kang tatlong reaction. So una, you have moment. Meron kang reaction Y. Meron kang reaction X. Ayan. So meron tayong internal hinge na binigay ngayon dito. Ano? So ito, you can see, so meron kang C, which is equivalent to 1. Ganun din sa kabila, kang 1. And dito, meron kang internal, meron kang hinge. Kung saan, kapag hinge, dalawa nga yung reaction natin. Ganyan. R. So dito, ilan yung reaction natin sa una? So ang R mo dito, di ba meron kang Rx and Ry. So dito sa una, fix. So meron kang tatlo. Dito sa hinge mo, so R is equals to at the other end, so that is also equivalent to. So again, if you're going to apply this equation, ano yung kakalabasan ng ating? So 3 plus 2 plus 2. So that is equivalent to 7. So that is greater than, equals, or less than C plus 3. Meron tayong internal hinge. So that is 1 plus 1, 2. Plus 3, our equation will be 7 plus or minus, 7 greater than or equals to, or less than 2 plus 3. So 2 plus 3, 5. Therefore, 7 is greater than 5. Ganyan yung magiging condition mo. Therefore, the problem is considered statically indeterminate. So, ibig sabihin, hindi mo siya masosolve using the following equation, yung equilibrium equation. So, kailangan mo maghanap ng dalawa pang additional equation. Okay. So, to know kung ilang degree yung kanyang indeterminacy, so ipagsusubtract mo lang itong dalawang number, itong 7 and 5. So, that will be 7 minus 5 or equals to 2. So, that is statically indeterminate to the second degree. So, ganyan lang guys ang pagkuha ng determinacy for the problems under the category of a beam element. Okay, so sa susunod na slide, meron pa tayong mga additional problems. Sabay-sabay natin isolve, okay? Okay, so sagutan natin yung mga practice problem pa dito. So, yan sa figure, meron kang continuous beam as shown. So, alamin natin yung mga given sa problem. So, dito, meron kang so dito meron kang reaction, okay? Meron kang support na hinge. So, ilan ang reaction sa hinge? Dalawa. So, isa, dalawa. Next, meron kang roller. So, again, kapag roller, isa, and perpendicular sa surface na pinagpapatungan. So, ito roller din. So, ganun din. Vertical. So, dito meron kang internal hinges na binigay. So, ano nga yung value ng ating C kapag internal hinge? So, that is equals to 1. This is also equals to 1. So, again, if you're going to apply the formula, R is equals or less than C plus 3, alamin natin kung ano or saan category papatak itong beam example na ito. So, again, R. So, ilan yung R natin? So, bilangin natin, guys. 1, 2, 3, 4, 5. So, we have 5 reactions. That is greater than or equals or less than. So, bilangin natin yung C. Sa dalawa. So, 2 plus 3. So, 5 greater than or equals 2 plus 3 or 5 equals to 5. Therefore, this problem is under the category of statically determinate. And ito ay stable. Ano? So, SD na lang yung sulat natin. Okay. So, let's proceed with the next problem. Okay, so dito, sa pangalawang example, meron ka again continuous beam. So, dito meron ka again na hinge support. So, ang reaction mo is dalawa. Dito sa gitna, meron kang isa. Hinge roller yan. So, meron ka ulit roller. And then dito, meron kang hinge. Okay? Dito, meron kang internal hinge. Is dalawa. Is equals to 1. Equals to 1. Ito, dalawa. Again, apply natin yung equation. So, R is greater than or equals or less than C plus 3. So, bilangin natin guys yung number of reaction. So, sabay-sabay tayo. 1, 2, 3, 4, 5, 6. So, meron ka ditong 6. So, greater than or equals or less than. So, isa, dalawa. 2 plus 3. Or that is 6 is greater than 5. Therefore, this problem is under the category of statically indeterminate. So, paano nga natin mahanap yung determinacy, yung indeterminacy? So, ang gawin mo, itong value ng 6, i-minus mo lang sa value ng 5. So, statically indeterminate to the first degree. Okay? So, isunod natin itong sunod na example. So, mapapansin nyo guys, meron ka ditong dash line. So, ano ba ang ibig sabihin ng dash line na yan? So, ito kasi, kahit tingnan mo na lang, ito is papatak sa category na unstable. Kasi ang dash line na yan, that represent na nagkaroon ka ng displacement. O yung portion na to, bumaba. Yan. Ito yung naging final position niya. Tapos ito yung naging final position. So nagkaroon ka ng displacement. Therefore, this structure is unstable. So kahit hindi na natin isolve. Pero pakita rin natin, tingnan natin if mag-stable nga siya. So ilan nga dito? So ito ay isa, dalawa. Ito, dalawa din since hinge. Ito, meron kang and dito, meron kang internal hinge. So, meron kang C is equals to 1. And then, dito, C. So, ilan ang ating reaction? So, 1, 2, 3, 4, 5. So, 5 is greater than or equals or less than. So, ilan yung ano natin? 2 plus 3. So, So ito ay 5 is equals to 5. Okay, so that is statically terminate if ang i-consider mo is yung equation. But then again, this dashed line represent a displacement which is going to happen into this continuous. Therefore, still the answer is unstable. Okay? Pag malilito ha. Next. So para sa sunod na problem, ayan, nagbigay na siya ng internal roller. Again, ano nga yung value ng ating C kapag internal roller? So dalawa. Ano? Then kapag internal hinge, that is equals to 1. So dito sa side na to, meron kang dalawang reaction. Since ito ay hinge, then followed by roller, so ang reaction may isa, and then meron ka ulit roller. So if you're going to solve for the value of the reaction, so ilan yung reaction natin? Bilangin natin. 1, 2, 3, 4. Greater than, equals, or less than. So ilan yung ating internal hinge and internal roller, or yung value ng C? So 1 plus 2, 3. Then plus, yan nga yung ating equilibrium of equation. Meron tayong tatlo. So therefore, the answer will be 4 less than 6. So ito is under the category of unstable. Okay? So okay lang kayo? So let's proceed with the next problem. So ito naman. Yan, meron tayong fixed connection. So ilan nga yung value ng reaction natin kapag fixed? Ilan nga ang ating reaction? So meron kang moment, kang vertical, and meron kang horizontal. So the value of this is R is equals to 3. Ganon din sa kabila, tatlo yung ating reaction. So dito meron kang mga value ng C. So meron ka ditong internal hinge, kung saan C is equals to 1. And then dito meron kang internal roller, from where the value is C is equals to 2. So the number of reaction, so 3 plus 3 equals to 6. Greater than or equals or less than, so 1 plus 2, or that is 3 plus 3, or we're going to solve that, so that is 6 equals to 6, and that is under the category of stable and terminate. So that is statically terminate, or SD. Okay, last, ayan, meron na naman pinakita doon sa diagram na dash line. So again, that represents na magkaaroon ka ng displacement. So even without solving this, I could say that beam system is under the category of unstable. Okay guys, so sa sunod na video natin, doon naman tayo sa truss. So ganun lang din to. Para lang tayong kinder o grade school na nagbibilang ng mga member, joints, reaction, etc. So I hope na-enjoy nyo tong topic na to kasi ito lang yung madali sa structural theory. Okay guys, see you on our next video.